So yeah, John. So welcome to the podcast, the Humanitarian Meetup event, and thanks a lot for joining us today. And we're excited to hear about your project.
You happy for me to take over the presenting? Okay. Okay, so a few words about me. For 10, 20 years, I've been doing work in financial services, data work of various sorts, from systems building through to data analytics. And I just came to this Meetup group little over a year ago. Find another use for the data skills. So within what I did as sort of employment, it was running development projects, delivery projects within financial services, doing then moving on to quite a lot of accounting, forensic data investigation type work. So lots of pulling together databases on the fly from diverse sources, and then putting a skin over the top of it to be able to go and investigate whatever needed to be investigated. So it was almost always a matter of working with whatever technology a client had on the table at any particular time. I apologize, my name will probably have come up on your screens as John Doe. I'm actually John Tomlinson. It's just a quirk of the Google setup for me to both have my Google desktop, my cloud desktop available to me, and log into a Google Meet. I've got to go with my Google sign-on, and I just put in John Doe late one night to get a sign-on going. So apologies for that. I'm John Tomlinson, although I'm here as John Doe on the screen. The project. Brent asked for somebody to look at the IATI data set that's being distributed and find a way of making it more accessible. And the first thing to do was to be able to get a hold of it and do something with the XML, which is original format. And then we looked at, can we take that and pour it into a database and then make that database accessible to a wider audience? And Brent proposed that we take the IATI data and pour it into a Firestore database, which is one of the standard tools on the Google Cloud platform. So I've been looking at this. I made a certain amount of progress and hit a certain number of challenges with it. And I put together a sort of 10 or so slides just to walk you through what it is, what I've done with it, and what the challenges are, and possibly, and with the intention of throwing it open to the floor to discuss where we go next with this, to be able to get a data set and tools over the data that are useful to this group for whatever we want to do within this group, and then to be able to provide services out to the wider world. So let me just, any questions before I start, or should I just wheel into running through the presentation?
Before we dig into it a little more, we have Roderick here, and I don't know if you'd like to just introduce yourself and tell folks a little bit more about what IATI is. If you, otherwise, I can do that.
Yeah, I guess you caught me there, Brent. Good job. Roderick Besseling. I've been working with IATI, the International Aid Transparency Initiative, for the past 8 years, both working for international NGOs and for donor governments like the Department for International Development, which is now the FCDO, and also the Netherlands Ministry of Foreign Affairs, where we wrote the guidelines for IATI reporting for implementing NGOs. What IATI in itself does is it takes the basic project information that you would have that you have on a project, let's say humanitarian project that you're implementing in Afghanistan, and you put that into an XML file instead of a Word template. So think of the fields in IATI such as it has a title, a description, it has dates, it has budgets, it has results, it has geographic location. So the idea is that we make all of this information transparent and accessible to anybody within the humanitarian and development sector, thereby increasing the effectiveness and the efficiency of how aid is delivered. The IATI registry, as it stands at the moment, as a data store, definitely has some challenges to it. So it's great to see the work that John is doing, and I'm very keen to see about his progress using Firestore. So I'll be around the whole session. So if there's any content questions, feel free to ask me. Thanks, John. Back to you.
Sorry, could I quickly ask a question here?
Please.
So in this effort of doing this in future, what happens to the documents that are already there in Word or PDF format?
Right now, most of IATI data is stored in an XML format, but there's actually fields within IATI that can refer to a document someplace else. And
yes.
So that's another challenge for John, and we can talk about that as well in terms of these sort of third level data sources. If you have a reference to a PDF file, how do we actually bring in the PDF file into the project as well? And John, before we get started, I just thought I'd mention that IATI is arguably the humanitarian's de facto information sharing standard. It's been around for over 10 years, and it's been slowly growing. It's sort of a collaboration between humanitarian organizations and aid development agencies. And when you think about tech and AI applications and such, you actually need you can benefit from a structured data source to run your applications. And really, from a technical standpoint, IATI is the best framework, best source of data out there. So this is a really important project to start thinking about how do we make IATI data accessible to the next generation applications. So, I just wanted to emphasize that and turn it back over to John. Thank you so much.
Okay, so what are we dealing with? Starting point is the aid agencies are publishing a collection of metrics, and they're supplied out in a set of XML files. The agencies, a variety of agencies are producing the data, and it's being aggregated into a single zip file, which is updated once a day. And that single zip file posted on a website, so it's available, anybody can download it. And that zip contains about 7,000 XMLs, and an agency may be contributing or maintaining one or several files within that data set and updating it. The period of update of any particular file within that set just depends on the agency and what they're doing. The XMLs are, as I say, published in this one whopping great zip file, updated daily. They all ought to conform to an XML schema definition, which is published by IATI as the standard. So you ought to be able to take any one of those XML files and test it against the XML schema definition files that IATI also publishes. Within that zip huge zip, there are also small numbers of JSON format files, and principally those are giving metadata, telling you a little bit about the nature of the XMLs that actually contain the meat of the information. And as Roderick mentioned earlier, the kind of information that's stored within those XMLs, I'll have a closer look at it in a moment, but it's descriptions, it's the identifiers of the activities that the aid agencies are engaged in, text descriptions of them, the locations where the work is done, start and end dates, spends. It's the basic parameters of each of the activities.
Before we get going, Marco, do you mind, Mirko, muting your microphone? I think you might be the only person that's unmuted, and then we'll.
Sorry.
Oh, no worries. All right, go ahead.
So, when I took this on, my intention was to take the daily zip, unpack it, throw it into a database, maintain that database with updating the database with the refreshed information on a daily basis, but then use that database to publish queries that would enable a wider audience to access the data, and to start providing summaries, visualizations, the things that would actually make this accessible. I had naively assumed that stripping the data out into a database would be a relatively trivial exercise, and I'd be able to move quickly onto the other pieces. It's turned out to be slightly more of a challenge, and I'll talk you through why that is. So the key point is that it's a zip file, and when you look at it, you discover that it's 9 gigs of data, 7,000 data files. That's a lot of data, and it's updated on a daily basis. So if you want to take that, pour it into a database, you've got to do it in a sensible period of time. If I've actually got here one of the that's the zip from the 5th of May, sorry, the 11th of May last year, and that's it as a zip file. What size is that? So that's 500 megs on disk. Oh, sorry. No, that's the dump I've unpacked. Bear with me a second. What size is that zip file? Yeah, the zip is 500 megs on disk, so on disk. So it's not a small item in its own right. And then when you start to unpack it, you get long lists of the JSON files it contains, and then you've got a whole structure that contains the folders of the myriad agencies contributing with the XMLs that they're supplying. So there's one of these every day, and so the exercise is to pour through all of these XMLs, pull the data out, and dump it then into a database. So, Google Firestore, available on the Google Cloud platform. Firestore is intrinsically a hierarchical database. So, at first sight, it's aligned to the structure we're dealing with. XML is intrinsically hierarchical. that's one of the XMLs. It's pretty small, but it's XML. So a whole series of indented data sets. That section I've just highlighted there, I don't know if it's too small for you to read, but that's a collection of, that's the lowest level leaf nodes. It's a set of countries and the percentages of particular spend that goes into each of the countries. So the data is layer upon layer of nested information that needs to be pulled out and held in an appropriate format. And Firestore nominally gives you this kind of structure. So at its highest level, you create a collection. Collection is a box. You can think of it like an array into which you can store a number of documents. Then Firestore works on the basis that alternately you have a collection, a set of documents. Under each document, you have further collections. Under those, you have further documents, further collections, further documents, spreading out downwards. So that's the nature of it. And at first sight, you say that aligns quite neatly to the intrinsically hierarchical structure that you've got within XML. And to some extent, yes, they do match. The challenge, though, is that Firestore has limits. It's a standard Google platform tool, and working with it, my impression is that it's optimized for persisting the back ends of large web-based applications. So persisting individual users' environments, many of them, but all in relatively similar format, and each of a relatively small size. So a document, the maximum document size that you can have, or the maximum size for any individual document within that structure, is 1 meg. So, and since the XMLs are of a variety of sizes, many of them well over 1 meg, then you can't just take an XML, a whole XML, and stuff it into one document. You've got to break the structure out into pieces, align it in that document collection, take the original XML structure, shred it into parts, and then spread it out rather than just storing it as a whole lump. But you've also got other restrictions you need to work with. You've got, you have, for the whole database, the maximum number of writes per second as 10,000 writes a second. And you've also got a limit on, at the database level, of how fast you can pour data in at 10 megabytes per second. And these are just limits that Google sets on an individual's, or rather, a database instant limit. There's also practical limits, like if you have a single processing thread trying to write into the database, each write has got a response time of 150 milliseconds. I'll come back to the implications of that in a moment. But those are limits that we have to work with. And remember, we're trying to pour in 9 gigabytes of data that gets updated on a daily basis. So you've got a lot of information. You can't take all day over it, literally cannot take all day over it. you've got, you have to take that and fit it in to the database confined by these limits. You've also got another practical consideration, which is the cost of doing this. You can look at this and say, it only cost 18 cents to do 100,000 writes to the database, and you can get 20,000 writes free each day. Well, that's, in some senses, quite a lot. But then you look at what we're dealing with and go, that's not actually much free data, and that 18 cents for 100,000 writes is going to add up when you try and pour 9 gigs of data into it. And we'll just run through the sums on that in a moment. To get the data out of the IATI structure and into Firestore, ideally you mirror the Firestore schema. So you mirror the XML schema in the Firestore schema so that the two are aligned. Now, basically, you're looking in the XML at elements. Parent elements have a number of child elements, which then in turn have multiple child elements. And the ideal mapping that you'd like to work with is to go a parent element within the XML becomes a document within Firestore, and each document within Firestore holds a number of collections, and into a collection you then put the child elements of the XML item that you're dealing with, so that you're doing a straightforward mapping of an XML element to a document item within the Firestore, and replicating that hierarchical structure that you see within the XML straight into the hierarchical structure of the Firestore. That would be ideal. And if you do that in practice, what you find is that each document ends up at about 200 bytes in size. But then you do some numbers and you go, that's 9 gigs of data split into chunks of 200 bytes. That's 45 million documents that you've wound up with by doing that shredding at that level. And if you're trying to do that with 10,000 documents per second, which is the database limit, the fastest you could possibly do it is in 1.25 hours. Just because of the number of documents. The sheer volume of data, the database says at 10 megabytes per second, the ultimate limit is you're not going to get your 9 gigs in there in under 15 minutes. If what you were doing was a single thread processing exercise that was writing to the database, waiting 150 milliseconds for the response to confirm the write is successful, and then doing the next, to get through your 9 gigs of data at 200 bytes a time, that's going to take you 78 days. It's utterly impractical. And also, shredded to that resolution, every time you write the data set in, it costs you $81 just because of the number of writes that you've got to go through to get that data set into that database. So those are the basics of the challenge that I'm dealing with. So what can be done to work around this? Well, if you take the the code that you're writing to pour the data into the database and multi-thread it, then you can get over the 150 millisecond database response time, because while one thread is waiting for the response, another thread is running. So you multi-thread it. And then you go, okay, multi-threading gets you somewhere on a single processor, but it's not by any means using up all of the capacity of the processor. Can you do better? Well, actually, Firestore allows you to do batch writes, so that rather than having a write with 100 millisecond response, 150 millisecond response time for a single document, you can write 500 documents in one go with that 150 millisecond response time. So that gives you a 2 order of magnitude improvement on the speed that you can get through just by doing the batching. And then you go, okay, I could run multiprocessing, or multiple processes within that single processor to get greater utilization of the processor. So I can do multiple threads on a single file. I can batch the writes off that single file. I can do multiple files at the same time. And, well, rather than doing this on my Mac at home, writing to a database in the Midwest somewhere, I can put the processing into the cloud, and maybe I can get some dent in that 150 milliseconds response time. Okay, so I spin up a processor in the on GCP and do the processing on that, and I've got somewhere, but I'm still nowhere near fast enough. And this is where I am at the moment. The next items that I need to look at to try and get this exercise to the speed that I need it are the 2 bullet points at the bottom of the page. So I know that I can set up high throughput processing within the Google Cloud Platform. So I can set up a master processor and run maybe 100 slave processors and distribute the work across that 100 processors. And ballpark estimates say that combining all of those techniques, the threading, the batching, the multiple processors, cloud-based, and then running something like 100 processors concurrently within the cloud, I can probably get close to the 1.25 hour limit for getting data into that database, which is just the limit set by the database rules and the number of documents that I've got to throw at it. And the last one is a thought, which is that I might be able to do something about that 200 bytes per document written to the database. And that is, this is a tree structure, and rather than breaking the tree down into its smallest leaf parts all the time, perhaps I could do a statistical analysis and see if I follow down a branch within the schema definition and look at how much volume of data different organizations are putting down that branch, I might, rather than having to split everything down into its rationally smallest component, might be able to say, statistically, most people only put 20K down at the end of this branch, and most people only put 50K down at the end of this branch, and thereby change the way I chop up the data into documents and collections to increase the average size of the document that I write, thereby reduce the number of documents, and thereby reduce the processing effort to get the data in. The way that I've done it at the moment is the most robust, in the sense that by chopping it into its smallest components, I'm assuming that I take no interest in how people will utilize the XML definition that they've been given. So they could put as much information into any particular branch as they like. They may have myriad funding units that they want to attach to a particular item. And by breaking it down into the smallest parts, they could put unlimited numbers of funding descriptions against any item anywhere in the database. But if I give everybody that total flexibility, the weighing against it is the problem that you end up with breaking it down into the largest possible number of individual documents that you've then got to store in the database. So that's, if we are to use Firestore as the database, that's the kind of trade-off that we need to look at. Now, just as context for this, in case anybody is interested, the way I've been doing the work on this is I prefer to be Mac-based, and so I've spent my life on a Mac Mini that's just running macOS Catalina. I've got Python 3.8 inside a virtual env environment. The reason for that is that although Python 3.9 is available, in the autumn, when I last looked at this, the Firestore tools were still at 3.8, so I didn't want to be running, they weren't happy in a 3.9 environment. And because I'd already got 3.9 installed on my Mac, and I wanted to be able to have different packages associated with my work in Firestore as opposed to anything else I was doing on the machine, then I've got multiple virtual env environments on my machine, and I just do my Firestore development within one of them. So that's the reason for that. I need an editor, and the free to download MS Visual Code Studio. Actually, although I'm not ordinarily a fan of Microsoft tools, that one is really good working environment. So it's become my my default context. And other bits and pieces I tend to write as shell scripts. For example, the download of the latest IATI zip file is simply a macOS shell script. I run it. It pulls the latest zip file off the website and unzips it into a folder. So that's my day-to-day. That's the working environment that I deal with. Of course, separate to that, I've got the work that I do with the Google Cloud Platform, which is simply a window into the GCP environment, and terminal windows in macOS that just convert to command line on CPUs running in the cloud. Couple
Mike,
of words about the.
Just before you go on to the next slide, Mike, you had a question. Maybe now's a good time. I think it had to do with the last slide.
Please forgive an ignorant question. It isn't clear to me that a daily update is actually required. Would it make things a lot easier for you if it was a batch job that ran every Saturday and Sunday? I can't imagine that the data has to be updated every single day. Thank you.
Go ahead, John.
I have not done an analysis of the amount of change within day to day within the zip file that's distributed. It's nice to have to be able to have the data that is published to the world as up to date as possible. The zip comes out on a daily basis. All of the XMLs within the zip have a last updated tag at the top level within the XML. So what the first step, if you're to do it on a daily basis, would simply be to run through the XMLs, look at the last update tag in each one, compare it to the database, and go, okay, all of these are the same. The updates are limited to these, so you can still pull it on a daily basis. The download is not a particularly heavy duty exercise, and how much update work is dependent on what level of changes within the file. And since you would either have to do the full week's updates once a week, or you do them bit at a time on a daily basis, I'm guessing it doesn't make that much difference to the overall processing. So it's kind of, at the moment, I have it in mind as one of those details I'll come to a little bit later down the line. But yes, good point.
And just in terms of a project, it's great to just start trying this out. This is our first attempt at this, and it's nice to think about, a daily update and start looking at all the, sooner and later on both sides. So, this is, I think this is a good starting point, and you've learned a lot just, trying to do, looking at it from a daily perspective.
Yes, I suppose I would, because it comes out on a daily basis, I would start with, can I update it? Can I maintain the database on a daily basis? And back off from that if there's a good reason for not doing so. So I go, can I do it at the most frequent? If I can, great. If I can't, okay, then how do I soften that requirement? And I would do it in that order.
Exactly. And Mirko, you mentioned your interest in natural language processing. And let's say I take my app and I say, hey, Siri, I would like to update my 8 activity file in real time. And you might update it 4 or 5 times a day. In the future, it's nice to be able to actually, in terms of a database, shorten these update times, looking forward to the future, to respond to needs in the field and the way the product is used. The way IATI will be used in 5 years might be an hour update window, so or shorter, who knows? But it, thinking about future applications.
But how does IATI do it today? I mean, they visibly have a database themselves where they store the data, right? I've just seen that they also have NoSQL. I mean, they have a Solar instance as well.
Mm-hmm. I think in terms of aid organizations individually, they attach an XML file to their websites, and IATI, in a sense, aggregates those together or makes them more visible. So in a sense, Oxfam, they could update their XML file, 100 times in a day, and that will be visible, in real time to anybody who bothers to look at that file. It's just the zip file is, only aggregated once a day. But in a sense, you could actually upload data directly from the websites, the URL addresses of these individual files. So that's another, in the future, that's another upload methodology, is to actually catalog all these locations where the files are stored and, you know, ping them every couple of minutes or hours for changes.
Okay, I mean, but IATI, the organization, does store the content in a centralized place as well, in a database, right? They already do that today, or I just went on the website. I wasn't, you know, I mean, there's a query builder and so on. So I suppose that there must be some database behind it that you can already query today. And I just wondered what they had chosen as a technology. I mean, if they're running that on their own infrastructure, then some of the problems that you've encountered, of course, they wouldn't have, like in terms of cost implications or simply data transfer time and so on. But yeah, I just wondered if, you know, if that's relevant in this context, how they're doing it.
Yeah,
but
that's a good question for Roderick, if you're available to answer it. But, you know, IATI is an initiative linking a lot of individuals and aid organizations and development agencies, and unfortunately their tech is not essentially up to date. So I think they don't, you know, go ahead, Roderick.
Yeah, no, sorry, great question, Nico. And I honestly have no idea. I know that the IATI registry itself was based on a CCAN instance, but I don't actually know what the backend database is that they're using. But indeed, they do have a database, at least, that you can use the IATI query to query the database, obviously. And I think this is also the same database that's used on dportal.org. So dportal.org is the visualization layer of everything that's in the IATI, let's say, database. But the challenge is, indeed, what Brett said as well, is that every organization just provides a link to where the file is hosted online. And then the IATI database or registry has to make a soup out of that data. So with the ingredients that it has. So
Yeah, and one last thing is, you know, looking at this project, IATI's, you know, the IATI APIs and the IATI resources, in a sense, you can't query every single information field, you know, in terms of drilling down and maybe aggregating different fields together and having a really creative, sophisticated query. It's just not possible to accomplish. So this is one of the goals behind John's project, is to, let's think about
I understand. No, and it's very interesting. Yeah, no, it's I see that. I just wondered how maybe some of these challenges that John has been describing, they're probably, you know, I mean, you know, this storage of XML in a tree architecture. Of course, in a relational database, you have other challenges, but still, some of these challenges might be similar to those that, you know, anyone who's been storing that data, processing it in some way or another, they may have find ways of doing it.
Sorry, and I hope I'm right in this. If you look at the IATI cloud on GitHub, they refer to Apache Solr. And again, apologies for my knowledge about databases is non-existent. So if I'm saying something silly, then let me know. But if you check on GitHub IATI cloud, it has a little bit about how it's...
Yes, even I was looking onto their site. So the IATI does have a data store. It gives an API as well to build queries. And it is indeed using Apache Solr, which seems to be a NoSQL database.
Thank you so much. John, do you want to, now that we've interrupted you, would you like to go on and finish your slide? I think you have one more or two. Maybe we'll and then talk some more afterwards.
I'll just run through the last couple of slides. This kind of input is what I was hoping to get out of this session, amongst other things, because I've just taken this as a very as a kind of depth first exercise. Brent asked, can I take this data set and pour it into a Firestore database? And I go, yeah, I'm sure I could do that. Let's try it and see what happens. So I have not gone scanning the wider world to see what's already out there. I was focused on the immediate challenge of, this is it. Let's see what I can do with it. but to get a community like this going, this is available on in this location with this means of query. Excellent. This is kind of information that's triggers me looking in other places in different ways. But just to finish up on this, taking the XML and putting it into the Firestore database, well, any hierarchical structure, there are some basic things that you have to deal with. You have attribute names, and if you run a standard package like Badgerfish, it gives you a means of converting XML into a Python dictionary structure, and it does things like attribute names. It prefixes with an @ symbol so that you don't get collisions between attribute names and child element names. It takes child elements and puts them into arrays within the Python dictionary. The core content of an element it labels with a $ symbol, so that you've got a key associated, a standard key associated with the contents of the element. So I just took the standard Badgerfish package, ran that against the XML, and wound up with the data from each of the XMLs loaded into Python dictionaries, and then was just running through the Python dictionary using the Firestore tools and throwing the contents of that Python dictionary at Firestore to persist it into the Firestore database. The only tweak that's necessary is that Badgerfish doesn't handle date timestamps, so I just enhanced it with a couple of regular expressions to convert the ISO date stamps in the IATI XML into the Python datetime class, which then gets persisted as date timestamps within Firestore. So then we come to the final slide that says, should we be going down this path? We know what we'd like to do, which is have our own database into which we can pour the data and then run our own tools over it for making the data accessible in a variety of ways, whether it be visualizations or to put something more sophisticated over it, like natural language processing to provide translations or indexing based on the descriptions within the data, things like that. So we need a database. Should it be Firestore? What are the flaws? Well, Firestore, it's GCP platform, it's globally accessible, it's software as a service, so it takes away a variety of database maintenance issues. The storage is effectively, for practical purposes, unlimited. It's as big as you want it to be. It's intrinsically a hierarchical structure, matches the stored, the source XML. The against is it's not optimized for this kind of purpose. So it's optimized for read modify writes on individual documents, so that if you log into some web application and you have a user context, Firestore is optimized for saving that user context and bringing it back to you next time you log in. One context per individual, not doing bringing together thousands and thousands of documents for a purpose. the billing structure weighs against performing analytics across the database, because the analytics requires you to touch thousands of documents every time you run a query. And Google will charge you every time you touch a document. That's just the way it is, because it's set up for a different purpose. Now, Google may be nice to us, and these kinds of restrictions may stop being a problem, but it's where we are at the moment. But we've also got that last one, which is that 1 meg limit on the size of the document, and those other constraints about speed of writing, along with things around the general structuring of the database, that it wasn't designed for this kind of function, mean that to some extent you're having to engineer the data to fit the database. So it's not a given that we can almost certainly, in fact we can definitely, take that 7,000 XML files, pour them into Firestore. First time we do it, it'll be $81, and it'll cost us a small number of dollars to maintain it on a daily basis. We can do it. And then the thing is, that's where I am. Should we? And then it leads on to the bigger question of, okay, if we do that, what is there anything different I ought to be doing about the way I'm putting the data in there? Or what sort of interfaces do we want to put over it? What sort of query tools do we want to have available? It's kind of, what are the functional requirements that we want from this data set as a whole? So that's it. That's where I am. Those are the kinds of questions I've got. Brent, back to you.
Thank you so much. Yeah, and this database is so important to be able to just approach those questions. And, you know, IATI it's a standardized framework, and there's standardized, you know, elements and information fields. And in a sense, if you have a database, you could actually generate a kind of a converter where you could execute queries against the database. And let's say we update the database, it's still useful to have these other half of these type of queries, this sort of query builder that we could actually change the information field names to accommodate different databases and things like that. So, you know, this is a great project just to evaluate types of databases, input challenges, you know, where it's kind of a cornerstone project just to get the ball rolling, to think about how we can store IATI data and how we can use it. And, you know, it's really important to do, you know, in spite of, you know, who knows where we'll be a year from now in terms of the types of databases we'll test and all of that. But this is a critical project just to start fleshing all this out. So, you know, I think it's an amazing thing to be working on. And as a group, you know, we, you know, I'm in contact with, you know, people with Python and Linux and, you know, these open source initiatives. We actually have the power to at scale look at all these different potential, you know, ways of dealing with this sort of data. And it's really cool, you know, that the humanitarian community and the tech community, they're not really set up to research these types of challenges. So, you know, we're in a unique position to be able to just look at, you know, on a wide level how to tackle this. So, you know, I think next steps is to upload data and then start looking at how we can actually take a simple query and execute it against the database and look at, you know, how does that query look and how do we accomplish it? Any other thoughts?
Oh, hi, Jonathan.
Hello.
Hi, nice to meet you. I was wondering, is there a way to access an XML file with directly with the URL to be imported into Neo4j?
You know, I'm not sure if we can actually access all the XML, the URL addresses of all these files. And again, there's over 1,000 organizations right now publishing 8 activity files. So in a sense, we could, you know, it's not that hard to generate a list of file URLs and then create some sort of a, you know, a program to take those aggregate them. That's
So
another.
we can do it then.
Yeah. And then another thought about this project, once we get this into a Firestore, we might be able to create a way to export that data into other types of databases. Because with this database, we have to process all the IATI data. And John, as you noticed, a lot of IATI data isn't necessarily reported properly, or it's not, there's inconsistencies in the way the files look. So let's say in the future we want, I'd like us to look at graph databases. So in the future, we might be able to build a graph database from the Firestore database in terms of pulling the data and dropping it into, the graph database, in a more clean fashion without having to do all the cleaning.
To come back to the previous question, there are a few aspects to that. The metadata that's published in the daily zip file contains the web address of all of the XMLs that are being distributed. So those JSON metadata files contain the addresses where the individual aid agencies are publishing the XMLs. So you could run through those metadata files, pull the URLs out, and compose yourself a list of the URLs from which you directly pull the XMLs, rather than pulling the zip file and pulling the XMLs out of the zip file. So you can cut out a part of the process. So you can, go and read those XMLs directly into whatever you want to read them into.
Cool, thanks. Yeah, I think that'd be a much better solution for Neo4j.
Okay.
And that's, we have this Meetup community, and we have over 15 local groups, and I'd like us this year to maybe have a product or two that we could make available to humanitarian actors. And one of the most simple things is even just to aggregate all these URLs, and this database can help with that. And other ways of aggregating the URLs, we can look at that as well. But step by step, it would be nice if the group could actually make resources available to the humanitarian community and the tech community, and beginning with easy ones and then work our way towards harder ones.
Is my screen still visible out there? Because what I've just put up onto my screen is the UNICEF Afghanistan JSON that I've pulled out of the zip file, and you'll see in that it's got a variety of information. I suspect I haven't actually gone through everything in there, but you will find that kind of information tucked away in that JSON.
Hi, John. Are you familiar with Neo4j?
I've never worked in Neo4j. I'm kind of aware of it, but not done anything serious with it.
Do you think it's a good application for this database?
I think there's
I'm not in a position to answer that. I don't know enough to be able to answer it.
And there's a lot of graph database experts that love the idea of using Neo4j to run AI applications and such. But we're it's a great thing. It'd be nice for us to look at different types of databases. John, you were starting to show off one of the XML files, and I just wanted to mention that a lot of the fields, they might have simplified information, and some information fields might have paragraphs of text that actually describe aid activity in human language. And it's kind of this is something also that we could have available to people, are these sort of chunks of text. And when you start training and testing AI applications, you need chunks of text, and that are contextual, so that we might be able to create a training data sets based on these descriptors and the related tags that might be useful in sort of identifying what the context, Afghanistan, refugees, a demographic, a location, and then see if the text, the processor can actually determine that from the text. So, that's a cool thing to look at in the future. Does anybody else? You go ahead.
Because I'm sharing my screen, my machine is running really slowly, but up on my screen at the moment is the representation of a very small XML file within the Firestore database, so that you can see in a column a document, the fields that are stored within that document. So there we've got attributes like the last updated date, the status of an activity, that kind of collection of atomic pieces of information. And then over on the right-hand side of the screen, it's you're drilling down into a description. So that's how the XML data winds up being represented under the covers within Firestore. Sorry, it just updates very, very slowly at the moment.
Yeah, and it's nice because it preserves most of the IATI's own information fields.
Oh, it's preserving absolutely everything that is originally within IATI. There's no loss of data within this exercise.
Yeah, this is really great. And again, executing a complex query is just something that's very difficult to do with IATI's own resources. So this is so cool that it enables that. So
one more question. Do you think using the metadata and the daily upload is the best way to get the URLs for the individual URLs?
IATI, they actually have a list, not necessarily a list of URLs, but you could actually create a small program to generate a list of the URLs from IATI's own website. And one of our members last year coded some of that, quick little program to pull those URLs. So we never actually finished the project, but it's an interesting start. It was we were able to prove that it's not that hard to do, just to strip IATI's own websites.
Cool, thanks.
Good. We're over our time slot, but does anybody else have any other questions or thoughts on this before we bring this to a close? So kind of looking forward, I'm going to send an update and a copy of this recording to members, and we're going to start. We have a Slack meetup group, a Slack workspace, and a GitHub account, and we're in the process of refreshing these things. But all of you are welcome to join in the project. Think about it, offer any thoughts, and help us as we move it forward and evolve it and expand it. So this was just a chance for all of us to kind of get acquainted with John and his work and the project and get to know each other a little bit. So I'd like to thank all of you for joining and sharing your thoughts. And thanks to John. You've been working, you've done so much work. It's amazing. And it's so cool.
Well, I suppose I'm just on the brink of being able to take all of that data and just pour it into Firestore. And as you and I were discussing earlier in the week, it's once I start doing that, I'm burning money. So that's the only reason I've held back at this point. And you're talking to Google to see whether they want to contribute on this, and to Microsoft to see whether they want to contribute on the Azure platform as an alternative place to host this. It's because we're a volunteer exercise, and if we go and put out a large database that lots of people are then accessing, there is a cost to it. And the more use it gets, the higher the cost is for those who stand behind it. So that was my only reason for holding back on throwing vast amounts of data at this thing, was just where are we going? What are we trying to achieve? Who's going to pick up the bill for this? But from a technical perspective, I'm pretty much there. I can just take this lot and throw it at the database, and then we start building queries over it.
This is a good point. And, looking forward, again, humanitarian AI in a lot of ways, there's a lot of interesting projects out there, but it's definitely an evolving field. And in a sense, we're looking forward 5 years or even shorter or longer, and thinking about what's the how do the next generation of applications look, and what's required to power them. And this is really important. So, it's good to think about the costs and what we can build, and how we can optimize these things. So well, thank you, all of you. And any closing thoughts from anyone? Or John, again, thank you for all your hard work, and Mirko, your input is really good, and all of your input has been amazing. And we'll just push this forward. And so we're going to try to have a discussion like this maybe once a month on a different project or the same project. And because of COVID, it's hard to have meetup events, live events. So that's why we've expanded. We have a podcast series, Humanitarian AI Today. And so we try to interview interesting people once a month. And we have a whole pipeline of people slated for this year. So if any of you would like to share news about your project on the podcast, or have some names of people you might think would be, great for us to interview, let me know. And we'll go from there. Anyway, so thank you, everyone. And
thank you.
Yeah.
Thank you.
And we'll meet again.
It's been great meeting all of you, and yeah, could talk all night, and I'm sure you've got vast amounts of very useful input. So look forward to catching up with you again when you guys can do the talking, and I will be quiet and listen.